Welcome to the podcast on dividing polynomials. I've got two division problems written up here at the top of the sheet. One is regular number division and one is a polynomial division. They're in the same form, 6205 divided by 23, 4x cubed minus 6x squared plus 1 divided by 2x plus 1. When we write this up to divide in long division, we put the 23, called the divisor, on the outside, and we put the number 6205 on the inside. Pre-work practice I did there that I got to get rid of. And we'll do the same thing over here. We put our divisor on the outside and we put our numerator, called the dividend, on the inside. Now notice the 0 in the 6205. That's a placeholder for tens. This number doesn't have any tens, so we put tens here. The 6 represents 10 cubes, or thousands. The 2 represents 10 squareds, or hundreds, and the 5 represents ones, or 10 to the zeros. Over here, instead of tens, we have x's. The 4 represents the x cubes, the negative 6 represents the x squareds, but we don't have any x's in this, so I put plus 0x, and the 0x is taking the same place as the 0 did in the regular number division. So now I've got every power of x listed in descending order. I begin to divide. In the numbers, we put 23 into 62. It goes twice. 2 times 23 is 46. Now over here, we don't know how many times 2x plus 1 goes into the first two terms. So what we're going to do instead is just put the 2x into the 4x cubed, because that's the best we can do. And the way you do that is you put 4x cubed divided by 2x, and you cancel, and you get 2x squared. So 2x goes into 4x cubed 2x squared times. And then over here we multiplied the 2 times the 23 to get the 46. So here we multiply the 2x squared by the 2x plus 1. And we get 4x cubed. And then 2x squared times plus 1 is plus 2x squared. Now over here we subtract and we get 16. So over here we want to subtract also, just like with the numbers. But when you subtract a polynomial, there's a bracket around the polynomial, so you have to distribute your negative, and that changes every sign. So I'm going to take the sign on the 4 and change it to a negative. And I'm going to take the sign on the plus 2 and change it to a negative. And now we add, and we get 0 here, and we get negative 8x squared here. Now, in the number division, we would next bring down the next number, so here we bring down the next number also, plus 0x. Now you can see why it's so important to put a 0x there, so you'll have something to bring down. 23 goes into 160. Well, 8 times won't work. What about 7? 1 too big. Let's try 6. 6 times 3 is 18. 6 times 2 is 12, as 1 is 13. We get 138. Now again over here we can't put the 2x plus 1 into the 8x squared plus 0x, so we just put the 2x into the negative 8x squared, and we get negative 4x. And just like over here we multiplied the 6 times the 23, over here we multiply the negative 4x times the 2x plus 1, and we get negative 8x squared minus 4x. Over here we subtract, and we get 22. And over here we're going to subtract the whole polynomial, so we have to change both signs. Negatives become positives, and add. And here we get 8x squared, negative 8x squared plus 8x squared, which is 0, and then 0x plus 4x is 4x. Here we bring the last number down, here we bring the last number down. 23 into 225, almost 10 times, so we'll say 9 times. 9 times 3 is 27. 9 times 2 is 18, and 2 is 20. Over here, 2x goes into 4x plus 2 times. 2x times 2x is 4x. 2x times 1 is 2. Here we subtract, and we get the remainder 18. Here, we change both signs and add, and we get negative 1. Final answer over here. Since the 18 is smaller than the 23, we're ready to write our remainder. Plus 18 over 23, which we write as the mixed number 269 and 18/23. But remember, there's a little plus sign right here that we're not showing. So over here we say plus -1 over 2x plus 1. In other words, I put my remainder over my divisor here for my remainder term, so I put my remainder over my divisor here for my remainder term. Now, is that really the quotient? Well, if we multiply the 2x plus 1 by the quotient, and we've got the quotient right, we should get what we started with, which was the dividend. So I've set that up down here. Now, I've already done it because it takes a long time and I don't have much time for the video, but just to get you started, you're going to take every term of this polynomial and multiply it by the 2x plus 1. So you're going to start off with 2x squared times 2x plus 1, and that's going to give you 4x squared plus 2x. Then you'll multiply here, then you'll multiply here. Then finally you'll do the -1 over 2x plus 1 times 2x plus 1. The 2x plus 1 on the bottom will cancel the 2x plus 1 on the top, so all that will be left is the -1 in the numerator. Okay? And when you combine your like terms, you do get exactly what you started with, so that is the correct answer. We could do the same thing over here. If I take the 23 and I multiply it by the 269 plus 18/23, and you kind of have to grab a calculator for this one. 23 times 269 is 6187. 23 times 18/23, the 23's cancel and I just get 18, and when I add them up I get 6205, so that answer does check out as well. Now, we're not normally going to be doing divisions with this complicated a divisor. We'll do it occasionally just to practice, but we're going to be more interested in simple divisors where the power of x is 1. So I've set up a second division problem right here. I've got my power of x in my divisor is 1 and my coefficient of x is 1. That's the most important case. So let's take a look and see what happens when we do that division. And I've done that division right here. And I've already worked it out because, again, I'm kind of hurt for a time factor. So you can go through the individual steps yourself. I've shown all the sign changes when I add the signs, and you can see that the division is right, but I want to point something out. Each time these first term results never result in anything. When I do 4x cubed and -4x cubed, I just get a 0. Positive 6x squared and -6x squared, I get a 0. Positive 18x and -18x, I get a 0. When the 4x squared is multiplied by the x, it never contributes anything to my answer. All my numbers come from the top numbers multiplying the -3. So the only thing that's really important in the division is the 3 and the thing inside the bracket. So this leads us to a new kind of division called synthetic division, which is really fast and really neat, and I want to show you that now. Now, every time before we do our add to create our new number, we always change the sign. So since we're going to be dividing by x minus 3, and since we're going to be changing signs every time, I just change the sign when I start to a positive 3. Now, I don't need to worry about the x's. The x's, I need to know the highest power, but I can tell that from the numbers. In other words, if there's 4 numbers, then the highest power is 3. So all I do is pick off the 4 numbers. Instead of putting 4x cubed, I just put a 4. -6x squared, just -6. 0x, just a 0, and plus 1, just a 1. Now notice that the first number in my answer is always the same as the first number in my problem if the coefficient of x is 1, which it is in our case. So for my first number of my answer, I'm just going to bring the 4 down. And here's all I have to do to get the other numbers in my answer. Take this 3, multiply the bottom number. That gives me 12. Place it right up here and add. Take the 3, multiply it by the bottom number. That gives me 18. Place it here and add. Take the bottom number, 18, multiply it by 3, place it here, and add. Now since I started off with x cubed, this number will have to now be the coefficient of x squared. So I'll write 4x squared plus 6x plus 18 plus 55 for my remainder over my x minus 3. And there is my answer in just seconds. What a powerful, fast, easy method. So much easier than all of this. Let's try it in a more complicated problem. Here I'm going to take my same divisor x minus 3, but I'm going to divide it into x to the 4th minus 81. Notice I'm missing an x cubed. I'm missing an x squared. I'm missing an x. So here's how I do it. The number multiplying x to the 4th is 1, so I write it here. I have no x cubed, so I put a 0 for my x cubed. Have no x squared. Have no x. I do have a constant, negative 81. If I wanted to figure out my highest power, I could just count from the right to the left. X to the 0, x to the 1, x to the 2, x to the 3, and x to the 4 for my highest power. Now again, here's that simple synthetic division process. Just bring your first number down. Multiply by the 3, write it here, and add. Multiply by the bottom number, write it here, and add. Multiply the 3 by the bottom number, write it here, and add. Multiply the 3 by the bottom number, write it here, and add. Since this was an x to the 4th, this will be an x cubed, so I write 1x cubed plus 3x squared plus 9x plus 27, and I don't get a remainder, and there is my quotient, and it just took seconds. Now, sometimes your numerator won't be lined up in descending powers of x. In my next problem, 2x minus 3x cubed over x plus 2, I'm in ascending powers of x instead of descending. I still have to start my dividend off with the coefficient of the highest power of x, which is x cubed. So I start off with negative 3 for my x cubed. I don't see any x squared, so I put a 0 for my x squared. I do have a 2 times x, so I put a 2 times the x, but I'm missing a constant term, so I put a 0 for my constant term. I'm dividing by x plus 2. Now over here, when I divided by x minus 3, I knew I have to change the sign each time, so I just changed the sign when I started to plus 3. Here I'm dividing by x plus 2, so I just changed the sign when I start to minus 2. Now the synthetic process begins. Bring down your first number. Multiply the negative 2 times that number, write it here, and add. Multiply the negative 2 by this number, write it here, and add. Multiply the negative 2 by this number, write it here, and add. Since this is x to the 0, x to the 1, x to the 2, x to the 3, this will be times x to the 2. So it'll be negative 3x squared plus 6x minus 10. This time I did get a remainder of 20, so plus 20 over x plus 2. Very fast division, and that completes the podcast on dividing polynomials.